Good afternoon, everybody, and welcome to Back to Basics. Today we're going to be talking about the volt. In addition to the electron, the volt, without the volt, electricity wouldn't happen. So let's find out today what a volt is. Now, a volt is defined as the difference in electric potential between 2 points of a conducting wire where an electric current of 1 ampere dissipates 1 watt of power between these points. That really doesn't give us a lot to work with, right? So let's make that go away. It is also equal to the potential difference between 2 parallel infinite planes, and I'm reading this verbatim because I could not remember this ever. The potential difference between 2 parallel infinite planes spaced 1 meter apart that creates an electric field of 1 Newton per coulomb. That also doesn't make a lot of sense for us. We can also say that it's the potential difference between 2 points that will impart 1 joule of energy per coulomb of charge that passes through it, which still doesn't make a terrific lot of sense because we don't know what a coulomb is yet. We'll be talking about that soon. So, let's express the volt with some mathematics. Now, there are a lot of ways that we can classify the volt in math. So we can start by saying a volt is equal to potential energy, which I'll just abbreviate as PE, over charge, which we can also say is equal to Newton meters over coulombs. We can also say it's equal to kilograms per meter squared over amperes per second cubed. I've never really quite understood this one, but it's in the book. But these don't really relate to anything in electronics, although they are alternate ways to calculate a volt. Now, when it comes to electronics, this next series of equations are the important ones. Most notably, volts equals amps times ohms. Hey, this looks familiar, doesn't it? V equals IR. That's Ohm's law. We'll go into more detail about Ohm's law later on. It is also equal to watts over amps. It is also equal to joules divided by coulombs. And it is also equal to electron volts over what was that term? Over elementary charge, which we talked about very basically in our previous video when we talked about the electron. So there's our mathematic way of looking at what a volt is. But let's visualize this a little bit differently to give you an idea of how voltage works in relation to a circuit. So let's imagine a big tank of water like this, and it's full up to here. Now, the pressure of the water down here would be the voltage. The water wants to move this way. Oof, that's a really terrible arrow that I was about to draw, and I just smeared dry erase marker all over my finger and made a huge mess. Anyway, so the water wants to move this way, and the pressure that the water has, the amount of water here, how hard it wants to move from this point to that point, is the voltage. So let's put in a little valve here. And then we'll let the water start coming out. That allows the voltage to begin flowing. And to give us a segue into our next video, because we'll be talking about the amp in our next video, The speed at which the water is being permitted to flow through this valve is amperage. So volts is how much pressure we have between this point and, let's just say, this other tank. How much pressure is pushing from here to here is our voltage. How badly does the electricity want to go from this point to that point? So I hope I've helped you understand the volt a little bit better. If you're watching this video on YouTube, these videos are released to my Patreon supporters 1 week before they're released on YouTube. So if you'd like to get these videos a little ahead of time, please consider checking out my Patreon here. Also consider subscribing to my channel here, and I'll throw a video that YouTube thinks you'll like here, and I'll put the Back to Basics playlist here. Thanks so much for watching, and we'll see you next week.